Hey guys, welcome back to yet another classic arcade repair. Today on the bench I have a Nibbler by Rock-Ola board set. Nibbler. Now I've got two of these in a row coming up. Well, I got one Nibbler and the other one is, I forget what it's even called. It's the same board. It's a Nibbler board. Yeah. It's the exact same board, but it's a different game. Pioneer Balloon. Not working. So, yeah, we're going to do both of these. I had to build the harness. I just got it all put together. And I put Nibbler on it. Parts, Nibbler. And this was what I went off of. And I've printed off the manual. It's got the schematics in it and everything. All this kind of good stuff. Yeah. Rock-Ola. So I think I'll maybe put in a little main gameplay here of Nibbler, and we'll see what Nibbler's supposed to look like, and then we'll go ahead and fire this one up and see what it looks like. All right, be right back. All right, well, I just fired it up. I'm running it off the Atari AR, and I did check the voltage right here at one of these chips, and it was 4.98 volts. But we get a blank screen. Nothing. So, yeah, I don't know if anything's supposed to be here. Yeah, nothing going on the Nibbler. No video. Alright, I think I'll separate the boards. And I think what I need to do is, see, I don't know if anything's supposed to be here. I don't even know if this is in the right way. It's not hot, so. I think the first thing I want to do is check the software. I want to dump all the software, make sure that I'm not missing chips, and all of that kind of stuff. So separate the boards, get the programmer out, drop all the software, and run it against ROM Ident, and see what we got. All right. I do hear the speaker buzzing, so I think the amp's working. Yeah, so, all right. Start with that. All right, I was just taking this board apart, and I've lifted this ROM up, getting ready to remove it, and I noticed it's in backwards. The notch is right there. So, yeah, that'd be bad. Yeah, so I'm going to continue and then continue on with that plan of just going through all of this software and seeing if it's any good. This is actually a RAM chip right here. So, yeah. All right. Okay, things I found when dumping the ROMs. Number one, which was weird, 12 and 14 are the same file. The same data is on these two chips. This chip, 15, was blank. And I bet you that's the one that was upside down. 15. Yes, 15. That one was in backwards, and it's blank, which means it's damaged. It's no good. So that one will have to be replaced. and then we'll see. It looks like there's a high score save or something or other on there. I don't know what this is. It says HSS. Yeah, it looks like we got a messed up set of ROMs. So I'll take this inside and run them against ROM ident, and then I'll download the actual. Yeah, I'll have the actual ROM file and kind of do some comparison. What am I missing? What do I have here? And I'll put together a complete ROM set. That might be all that's wrong with this, is just, bad ROMs. So we'll see. Well, let's at least get that situated and get some good chips in there. All right. All right, after running the ROMs that I dumped through ROM ident, it's a mess. The one that was marked, no, the one that was in IC9's spot was actually supposed to be in IC17. The one that was in IC10's spot was not in MAME. That was that one that was the high score save or whatever. The one in the 12 position was IC12. The one in 14, remember they were the same file. That one is also IC12. 15 is the one that was empty because it was in backwards. That one was not in MAME. 16 is actually IC15. 17 is actually IC8. And then these are the graphics. These are the two on the graphics board. 50 and 51 are actually 50 and 51. And then 51 on the CPU board is actually a Pioneer Balloon ROM. And then 53 on the CPU board, I believe that's the sound ROM, is actually Pioneer Balloon. So yeah, this is a mess. We had ROMs that were not in MAME. We had ROMs that are the wrong game. And we had ROMs in the wrong spot. And two of the same ROM. So yeah, this was a mess. So I'll have to straighten this out and get a proper set of ROMs for this. And I'll go from there. Alright, after going through the ROMs, and I put some new labels on the ones that were verified. So we have 12, 15, 16, 50 and 53. Those are on the graphics board. Or not 53, but 50 and 51. And this is ROM 8. You can see I circled the 8 on the end. That one verified as ROM 8. IC8, I should say. So we actually still need 7, 9 and 10, 14, and 50, 52 or 51, one of the 2716s. Yeah, so see which one it is. IC 51, 52 and 53. I've got 53, so I need IC 52. So I still need about 5 ROMs. Now, this customer did send along some ROMs, and what I went and did was I verified. First, these were the ones that were on the board that verified, and then these were the extra ones. And this one with the dot on it, that was the one that was in upside down. I'm going to try to erase it and reprogram it, but I think that one's going to end up being garbage. But a lot of these ROMs that he sent along were duplicates. So I'm going to just erase them and make a full ROM set. I don't have any other. Yeah, I do have 2716s. There's a 2716. And I think there's another one in here. Maybe. 32. Yeah, just the one. That's all I need, though. I only need one. So, yeah, and here's the Pioneer balloon ROMs that were in this board. They got those labeled. Yeah, so sorting everything out, I'm going to go ahead and erase all of these and then do some programming to complete the set, and that should get us to where we need to be. Yep, got this guy in there with that. This is the one that was in backwards, and tried to program it, and it comes up with an error. So yeah, that one's just garbage. Alright, Nibbler. So I've got a complete set of EEPROMs, set of ROMs. I tested all of the RAM that was on. There's like 6 2114 RAMs and 2 2128 RAMs on the video board. I tested all those. Those were good. This is a 1K RAM right here. I cannot test this because I just don't have a way to test this. 6502 may have been in backwards. I'm not exactly sure when I got it. There's a RAM. No, that's not a RAM. That is a selector. That's going to be your ROM selector. Yeah. I got it powered up, and I since remember that one chip was that IC15 or whatever was in backwards, so it was drawing a little more current than it should through that chip. So when I've got everything in right, I powered it up and I was getting 5.25, or it might even 5.3, something like 5.3 volts. So I backed it down to 5.00. So it's perfect right now at 5 volts. And we just got an empty screen. So there's nothing going on. One thing that kind of concerns me right off of the bat is this video board has a 40-pin chip on it, and they call it a CRT controller. Now, what in the world is a CRT controller? Is that a video chip that puts out RGB signal? You know, that's just something that's in the back of my head right now. I don't know what that is. I have to look at the schematic, and I do have that right here. So I think the first thing I want to do is I want to remove this socket right here so that I can use my 6502 Fluke Pod on this to go over my RAM and ROMs here. I think that'd be a good place to start and see if I can communicate with the video board, because you got to be able to talk to the video RAM and all that good stuff. So I believe this is 0 to 3F. 0 to 3FF is this guy right here. Yeah, so I think. I don't know, I got that wrote down somewhere. Yeah, yes. Yeah, it is. 0 to 3FF. So that's going to, my guess is that's this chip. And then we have, on the video board, those right there. Yeah, so, and then here's all of the RAMs, or the ROM stuff. Yeah, the chip, the offset, and the Fluke signature. So I got all that ready to go. So I think next is, yeah, I need to remove this so that I can use my Fluke Pod and see what the CPU is doing. I think maybe I'll check and see if this thing is, put the logic probe on it and see if it's chirping, the pin 40, the reset. I think I'll do that first and just see if this thing's resetting. Probe around the CPU and see what it's sounding like, what it's looking like, and then eventually I'm going to end up putting the Fluke on this thing. But let's just do a little bit of poking around first, just for fun, 'cause that's always fun. Okay, well, I got my logic probe out and started probing around, and I was getting no nothing on pin 40, which is a reset on a 6502. So I decided, I was like, that's kind of funny. So I decided to call on the services of the little scope and started poking around, and if we look at pin 40, it is floating. And if I go on the socket pin, it's still floating. So we have no reset signal. Now, I know that there is on the, where is it? This Nibbler, this is the edge connector. Now I know that we have, where'd you go? Right here, pin 7. Pin 7 on the solder side is reset. Does this have an external reset? I'm going to have to look at the schematic. It looks like it might have an external reset. And I mean, it seems like this thing should still throw up garbage on the screen, but maybe not. Maybe I don't know. I don't know. So yeah. But anyway, that's a problem. That's no reset. Now, if I look at the clocking signals, this is the incoming clock, the outgoing clock. .4 megahertz is kind of a weird frequency for that to be. Let me yeah, 1.4 megahertz. It could be fine though. Who knows? I don't know. I don't know just yet. So I'm going to take a peek at the schematic and find out about this reset circuit. What's going on with the reset circuit? Because this ain't going to do anything without a reset. Without reset being operational. So let me take a look at that and I'll be right back. Okay, right here we have a 555 timer, and its output goes through this gate, which is a it's an 05, which is an open collector inverting gate, and it's got its pull up right here, so it should be pulled high unless it's driven low. So if you have a 0 on here, this should be high, right? It's going to be pulled high through this resistor. That's R1. And if we look at pin 3 of our 555, it's right here. And we have a low signal on there. Okay? Now that goes through this. This is that 05 right here. And it goes into pin 3. Okay, there's the low on pin 3. Now we go to pin 4, and we have that floating signal. Now that should be high, right? If this thing is shorted to ground, and pin 4 is being shunt right to ground, here's that resistor, R1, and it's 5 volts on one side. Remember, it's a pull-up. So there it is on that side. On the other side, it should be pulling that line high. And on the other side, it's floating. It's fighting with that 05 is what's going on. We have a bad chip right here, 05. So we'll go ahead, and this does not have an external reset. That's the reset circuit. So we need to replace this 05. Okay, you got a new 05 in the board. And if I look at reset signal now, it's still floating. Something else on that reset line is dragging it. So something that is connected to reset is messing with that. So I think what I'm going to do is just remove this chip, because this may have been in backwards. I don't know. I want to remove this and then test that line. So if I just turn it off, remove it, turn it back on, and look at that line, and it's still floating. Okay, so something attached to reset is holding it low. It's not actually a floating line, it's just that it's being held low. Okay. Alright, well, I'm going to, I guess, I don't know, maybe I should go by feel. Anything super hot? You know what I can do is I'll disconnect this from this board and then see what we get. See if it's still, that would eliminate this board, right? The bottom board. If I disconnect these and it's no longer held, you know, but if it's still held, then it would be this board. But if it goes free, it would be the bottom board. So let's do that. Let me turn this thing off again. And I'll be back. Let me unhook these. Okay, disconnected the bottom board. And now I put the chip back in. And look at that. No longer held. So something on the bottom board is holding reset low. Yeah. So that chip wasn't bad. Chances are it was not bad. There's a lot of them old stinking Fujitsu parts on this board. A lot of them. Quite a few actually. Those are notoriously bad parts. Anyway, let's go ahead and turn this back off, and we'll have to flip this thing over and start looking on the other board. I just want to inspect the board first, and I'm going to look at how many Fujitsu parts are on this board and start going with the obvious stuff that reset would be hooked to. We might have reset hooked to counters or latches and stuff like that. So yeah, let's check some stuff out. All right. So, how many of you saw the error of my ways? How many of you noticed something that I had wrong? Anybody? I wish we could stop the video and like put up a comment section. I had the boards hooked up wrong. I had this one basically like flipped. They're supposed to be parts side out on both boards. I had this one flipped. Anyway, yeah, so great. But we get this, and I now have this on the monitor. I got to straighten up the horizontal frequency a little bit. Got a little curl going on up here. Yeah, so at least we got some video now. Nibbler. So looks like we still have a CPU board problem because it comes to that. Let's turn it off. Try it again. Okay, it went through and it did some stuff like it was saying. I saw it say fail on a couple of things. So I want to zoom in and check that out again. Okay, fail, fail, IC32. I saw IC32 fail. I wish I could just... Is there a reset button? There isn't. I hate turning this on and off like that. 32, I can't, I don't know. I'm going to try to take a picture of it this time. Get my camera ready for a photo. Okay, and this time it didn't do anything. I'm right here ready to take a picture and it didn't do anything. And now it's not doing nothing. Okay. Well, it's a CPU board issue. So, like I said before, I will go ahead and remove this socket. Remove this socket and get the fluke on this thing. IC32 it said was bad. What is IC32? It's one of these. I doubt that. I think that's just garbage. So, yeah. Yeah, I'm going to go ahead, remove this, and put the fluke on this and do my RAM and ROM stuff. Let's do that. Okay, weirdness. So I got new socket on here and I'm fluking this thing. And I've gone through and made my notes here. Uh, 4,000 is okay. 5,000 gives the pod a timeout. 6,000 is okay. 7,000 is a timeout. 3,000 is the incorrect signature. 8,000 okay. 9 okay. 8. A000 is another timeout. So there's 3 timeouts. And B was okay. So A, 7, and 5 are timeouts. A is 16, that's this one. 7 is 4,000, this one right here. No, 7 is IC10. I don't think that one's giving me a timeout. That is 7992. Yeah, it did give me a timeout. That was IC10. This one. And let's restart this. Some of these ROMs are just no good. This one's no good. Let's move this one to right here. That's IC16 slot. That's A. So let's go ROM at A. And IC10 was 7992. Yeah, timeout. And let's get rid of this one. Well, these 3 ROMs right here. This one's intermittent. This one will work every now and again. But now, if I do that again, that IC16 was A. Let's go ROM at A. to AFFF and just go with it. It should not give me a timeout. It should go all the way through and just come up empty. Yeah, it just comes up empty. These 3 ROMs are no good. So I'm going to have to program 3 new ROMs again. This RAM is good. That's 0 to 3FF. RAM 0 to 3FF. Okay, it was good. Oh, it's doing pod timeout. Man, this thing's weird. I don't know. I don't know if it's my connection. I have to reset it now. I have to turn it off, turn it back on. Okay. I don't know. I don't know. I don't know what's going on. I don't know if it's my Fluke setup with this cable or if it's the actual parts. I really don't know what's going on. So I'm just going to have to keep messing around with this. Alright, yeah, well, when I was doing those tests, I forgot that I had unplugged this board, and a lot of the decoding for this circuitry is on this board. So that's why I couldn't get through to any of that. Any of the RAM. Now the RAM's fine. I'm doing 0 to 3FF. And that's fine. That's that RAM under here. And then some of these are 4000 to 7FF. And then 4 to 7, 8 to BFF. And then I think that's all that the CPU can access, I think. So if I go RAM 4000 or 400 to 7FF, that'll be okay. Okay, and then 800 to BFF. Those are the 2 video RAM. Those are the 2 video RAM ranges, and I believe that's all that the CPU can access. Although I do want to try something. See, now this should beep at me when I do C0 to... Yeah. But I want to try something. Yeah. Yeah, those are color and character RAM. Color and character RAM. That's not for the CPU to access, I don't believe. That's these 2 guys. And 2 of these are used for color and character, I believe. Yeah. Or just color. 2 of them are color RAM. These are the character RAM, I believe. Yeah. Alright, I'm going to continue doing some testing. Alright, well, I do want to show this again. This is IC8, and this is an original ROM, and that is 5000. So if I do a ROM from 5000 to 5FFF, and I don't care about the signature, see, it does a pod timeout. Now if I got to reset it, so I turn it off, hit bus, turn it back on, and it gives me bus test OK. Now I want to just pop this ROM out of here. Remember, this one would give me a pod timeout. So now I'll just go ROM, and I don't care. Oh, it's giving me timeout again. So that was unexpected. Ah, shit, this damn thing. I don't know. I don't know. I'm just going to keep trying to plug away at it. It's confusing and ridiculous. Okay, I decided to just keep the ROMs out. This thing, with giving me pod timeouts all the time, it has to be some kind of a signal that's missing or corrupted or something. So I just took the Fluke off of it, put the CPU back in it, and I'm probing around, and I've come to something that is definitely dead. It is a Fujitsu part, and it's a 74. You can see right here, both sides of this are completely dead. That's the clear, no clear. There's your data, and your clock is twice as fast as the data. So you're going to have a signal that looks like this, basically, on the outputs. There's no preset. Preset's pulled high. And here's the outputs. This is Q, low, and not Q, garbage. And then on the other side, the high side, we have, that's the clear signal, no clear. And the same thing, data. And that is your clock. So you're going to have a signal that looks like this. And here's the preset, no preset. And here's the output, floating. And Q naught is also floating. So this Fujitsu chip right here is completely dead. I'm just going to keep poking around. I'm going to keep probing these Fujitsu parts. This one's definitely got to go. And if we look at what that is, let's find that chip. 25, right here. That's some kind of enable. I think that's not G, maybe. I don't know. I don't know what that says either. Those two signals are missing. So we'll have to... I'm going to try to look around the schematic and find out what... try to determine what that is, actually. Yeah. I don't know. I'll be back. I'm gonna look around for these signals. Okay, I think I found one of those signals. I believe that this one right here is F1. Okay? And that I found right here. This is all CPU control, data control, you know, write controls and stuff like that. And it's processed right here and creates this write enable, which goes up, and it is with this RAM. So it's amazing that this worked at all. If we look at this gate right here, this is 36, which is right here. Here's our missing signal. Sorry. That's our missing signal, and it's processed with this signal, which this is the right clock signal, and this is what the output is. It's really amazing that this works at all, to be honest. Yeah, but yeah, this chip's got to go. This 74 right here. So we'll do that. Get that out of here. The good news is this board, well, it does have some Fujitsu parts. There's one, there's one. Not many. So let's go ahead and get that thing out of there and see what happens. Okay, I got a new 74 in. I've got it turned on. And we're back to this. We're back to our grid. I adjusted that little curl out of it. And the cool thing is, I'll put this back. Remember how I was trying to capture that error message? I saw that error message again. So if we do this, and you'll see down around here, there's a failure message down around in this area. So let's try to catch that. I'm going to turn it off and turn it back on. It's down here. 12 and 8. It was 12 and 8 failed. Let's try it again. 8, 12. Everything else looked like it passed. And remember, I had a problem with this chip would set the pod into timeout. That's 8. And this one's 12, which when I was doing my testing, 12 would give me the incorrect signature of C97A, and it was supposed to be 1264. So I'm going to have to replace this chip and this chip, and then hopefully we might be good to go. So let me burn a couple new chips for these two spots. New 8, new 12. Nibbler. Oh boy, let's play some Nibbler. Alright, I'm going to go turn down the lights. Nibbler. Ooh. And let's see how this... Interesting. Alright, let's do it again. Dang it. Holy crap. Awesome. I can honestly say this is my first time ever playing Nibbler. Excuse me for a second. I guess I can't get at that pot. Go turn on the lights. Just trying to get at that horizontal hold pot. I just can't get to it. I can't see what I'm doing. If I could get it to stay like that. Oh heck, let's play one more time with the lights on. Dang it. Damn it. I really like this. This is my first time ever playing this. Darn it, what am I doing? Nibbler. Yeah, that's my first time ever playing Nibbler. I like it. That is a fun game. Alright. Well, what did we do with Nibbler? Well, I had to basically completely redo the ROMs. I replaced that socket. I replaced this chip. This chip was dead. I had to program proper sound ROMs for it, and that's it. I cleaned the chips on the back side, on the backboard. I just cleaned. Yeah. So basically, we had a completely bad ROM set, and we had one dead chip right here. Yeah, so, and if you remember I was getting the grid screen before. I think this chip died during that. Yeah, so, yeah, I'll go ahead and let this one run for a few hours, 3 or 4 hours. I'll come out and play it every now and again, because I do like this. This is a fun game. So Nibbler, the Nibbler. That's one half of this repair. I'm going to post this one, of course, and then I'm going to go right into the next one, which is Pioneer Balloon, which is, it's a Nibbler board, same board. This is Pioneer Balloon. And, oh boy, there is no amp. I don't know what's going on with that. This one must have an external amplifier. It looks like it's got some soldered junk up here. Yeah, it's the same board. So we'll go ahead and, oh no, I hope all these sockets aren't these types of sockets. It's basically Atari sockets. Yeah, same board. Yeah, so this one will be next. Pioneer Balloon. Okay. Thanks a lot, everybody. Big shout out to everyone who supports the channel and who subscribes to the channel. Big shout out to all the channel members and the Patreon, my Patreon army. Appreciate y'all, of course. And yeah, we'll see you all on the next one. We'll see you on this one right here. This is going to be the next upload, Pioneer Balloon. Unless this thing fails in the next 3 or 4 hours. So yeah, see you then. Bye for now.